Cornwall is one of Britain's most popular holiday destinations. It is also currently receiving Objective 1 funding from the EU. This makes it an appealing location for suitable investors. We have chosen Newquay in Cornwall to take our idea for establishing a commercial spaceport in part for these reasons. This video will display our designs and ideas for this vision before discussing how OCUVI will deliver it and the financial return we are predicting. We're not launching rockets to the moon. We'll be providing the facilities for companies such as Virgin Galactic to come in and provide pleasure trips to the outer atmosphere, with the capability of extending into satellite launches in the future. Sounds like a science fiction dream? Well, dreams inspire reality. This is our vision, to create a spaceport at Newquay's airport, to enhance the current airside facilities, and to sustain the local area with increased business and opportunity. We are OCUVI. So let's meet the team. Directing the project, we have Douglas Megwin. He's also our lead mechanical engineer. Maxine Mead is also a project director and works to coordinate all team members' efforts. Lloyd Wheeler is a mechanical engineer and has led the team in our project risk assessments. Edward Stowe is the team's lead structural engineer and has led in our external communications. Zainab Nuruddin is an architectural designer as well as a structural engineer for the team. Joss Knight is a civil engineer and has led the team through the video production. We are all highly skilled individuals but come together as something more. We are an effective team capable of achieving anything. OCUVI, delivering sustainable development projects through a blend of design creativity and engineering excellence since 2014. So let's look at our designs. 2 detailed designs and 6 outline designs have been produced. First, in detail, the spaceport itself. The spaceport complex is approximately 25,000 meters squared, which is in line with the current Spaceport America. The spaceport complex has been designed to Eurocode 1, Action on Structures, Eurocode 2, Design of Concrete Structures, Eurocode 3, Design of Steel Structures, Eurocode 4, Design of Composite and Steel Structures, and Eurocode 5, Design of Masonry Structures. In addition to these standards, the complex has been designed to achieve a BREEAM Outstanding rating. Within the complex, there is a reception area, including check-in desks, a hangar with approximately 5,000 meters squared of open bays to accommodate 2 of Virgin Galactic's White Knight 2s. This hangar will utilize a set of horizontal leaf sliding doors for access. The span of the hangar entrance is broken up into staggered sections so that the leaves can slide between one another when fully open. The doors sit on hardened rails embedded into the concrete, allowing them to move freely sideways. The facility will also include office space for spaceport staff and spaceflight operators, as well as training facilities, lecture rooms, and a flight simulator. The departure lounge will have views of the sea and runway. The astronauts' guests may stay here during the spaceflight. There is a high-quality restaurant with views of the sea and runway, which will be open to the public when not in use by passengers. The underground car park has capacity for 80 vehicles. To achieve the desired BREEAM rating, several sustainable techniques have been employed on the spaceport. EFTE will be used as an outer skin to form a 2-layer facade. The materials will have the appearance of a multi-layered cushion and will help keep the building insulated and also ventilated due to the mechanical vents at particular levels. Within the EFTE will be lights which will change colour and create patterns on the outside of the spaceport. There is a maintenance walkway between the EFTE and the inner walls and the windows of the spaceport. This concludes our spaceport design, which is our main deliverable and flagship element. However, as part of this project, there are several other designs to look at. The second detailed design for this project is focused on the installation of a 2 megawatt biomass plant on site. The plant will be a considerable step in reducing the infrastructure's carbon footprint and thus helping to achieve Newquay's airport carbon neutrality goal. The biomass CHP plant has been designed to provide a constant baseload of power to the building throughout the entire year, and in the event of excess electricity being produced, the airport can sell it back to the national grid, earning the airport's revenue. The plant is composed of several different components. The first is a 2 megawatt Mawera biomass boiler. The boiler is capable of burning wood pellets, bark, green cuttings, and wood chips. The heat energy produced in the boiler passes through a Siemens Organic Rankine cycle turbine and generator. A Siemens condenser recovers heat from the exhaust gases, which can then be distributed around site. A multi-stage combustion gas filtration system removes the majority of particulates from the boiler exhaust gases before they are released into the atmosphere. The whole complex is located underground and has a hinged access door for restocking fuel. The terminal building is delivered as an outline design element of the project, as the client wishes to build it once the current terminal is insufficient to support the forecasted demand. The building is designed to Eurocode standards and against assessment criteria that advocate sustainable development to provide energy-efficient, environmentally sound solutions. This is ensured by following a design process that aims to evaluate the responsiveness of the design to the needs of the project stakeholders and the community of Cornwall. The design concept is coherent with the other elements of the master plan provided by OCUVI. Baggage handling system is a major component of the airport terminal. Its effectiveness will have a large influence on the functioning and efficiency of the entire airport. A C-Bag smart system developed by Simons has been selected to perform this role. Its capacity of 1,500 bags an hour and 4 million passengers per year more than covers the airport's short and long-term growth targets. This system's all-in-one modular design enables easy modification and great flexibility to changing demands and circumstances. In a bid to increase revenue, OCUVI have produced an outline design for a large hangar complex that can accommodate 2 Airbus A380s. 2 pointed hangars combine to create an innovative new shape that reduces the amount of disused space. The reception, hangar workshops, parts, storage and facilities lie between the 2 hangars. Part of the adjacent building has also been designated as office space, which can be let out at a competitive price. The complex is constructed from large steel columns supporting a collection of steel trusses which span up to 95 metres. The hangars are clad in green, translucent polycarbonate sheets that reduce the need for artificial light. Each hangar will have a Megadoor VL3190 door, allowing the world's largest planes comfortable access to a secure and protected environment. As part of this project, there is a requirement for Newquay's runway to be extended to 3,000 metres in order to allow space-capable flights, as well as larger commercial flights, to be able to take off and land, therefore bringing in more revenue and business to the airport in Cornwall. So we have produced an outline design for a runway extension. A typical runway cross-section includes open graded pervious asphalt, allowing for drainage, a bituminous material, a lean concrete and a granular base. This runway will have a longitudinal gradient no greater than 0.8% to ensure it is safe to land on. This has been designed according to CAP 168. There is a requirement to provide a road system allowing new builds to be connected to public access. This will ensure our facility is easily accessible to its users. A typical cross-section as given by the Highways Agency in the DMRB will be used, as well as the standard road markings and signage. A drainage scheme has been produced to ensure that surface water on the runways and all the new builds is managed to mitigate the impact of flooding. A swale along the terminal access road and a system of filter drains surrounding the new runway extension have been designed in detail. The other drainage systems are shown in outline. These include the use of slot drains around the terminal and a detention basin feeding into a grey water system for the spaceport. These have been produced in line with the DMRB and using guidance available in the SUDS manual, as well as the table for hydraulic design of pipes, sewers and channels. OCUVI has carried out the design of the redevelopment of Newquay Airport to the relevant European and British standards, but also to the environmental standard of BREEAM Excellent, through the planning of using locally sourced materials, rainwater harvesting and renewable energy. During the construction stage, to ensure the approved designs and that the designs are constructed to the correct standards, 2 OCUVI personnel will oversee the construction process on site and liaise with the client and the contractor throughout this period. This will guarantee that our high standards are met and that the designs are followed, ensuring that the project is constructed to specification, and will also minimise any time for solving design issues which may arise during construction. A failure mode effect and criticality analysis was used during the design phase of the biomass plant, focusing on its design, construction and operation. This will remove or mitigate any potential risks associated with the plant to deliver a functional and successful design solution. Risk management has been a key part of OCUVI's overall project management strategy throughout this redevelopment project. Systems have been installed for adding new risks along with Risk Register to document, assess and provide mitigating actions to any risks that may arise throughout the completion of the project. Several Gantt charts have been produced along the design phase. The initial feasibility study, design specification and project execution plan on how to deliver the specification took 2 months. The design process was initiated at the start of January 2015. The total design of each project element took 3 months. There will be a consultation period of 3 months beginning in September 2015. Any changes required and updating of structural calculations has a contingency period of also 3 months. The project will go out for tender for a timescale of 95 days at the end of May 2016. Construction will begin in October 2016 and take approximately 1.5 years. The roads and drainage will take 4 months and cost just less than £4 million. The runway extension will take 6 days and cost £33 million. The spaceport complex construction, which includes the biomass plant, will take 10.5 months, costing £67 million. The airport terminal, including the baggage handling construction, will take 18 months and cost around £61 million. Construction of the new maintenance hangar will take 5 months, costing £35 million. Including OCUVI's 4.5% fee, inflation, a regional adjustment factor, and a contingency of 10%, the total cost of the redevelopment project is £256.5 million. OCUVI has generated some business return and investment predictions. The main generated revenue for Newquay's airport will come from the airport terminal, which will retail £2.1 million per annum, and the airlines, who will be charged over £28 million each year. The hangar spaces and office spaces will earn over £1 million every year. The biomass plant should earn around £600,000 in savings and selling back to the national grid. The spaceport will earn £14 million a year, charging the flight providers. Additional tourism should bring in £700,000. The total revenue is approximately £48.5 million. With running costs of £8 million a year, the project will break even after approximately 6.5 years. These are the primary stakeholders who are currently involved with Newquay Airport and will be involved if the project goes ahead. Cornwall Council is the largest stakeholder, as it is currently the owner and operator of Newquay Airport. The needs of the stakeholders have been addressed and achieved through the project's creation of sustainable designs, such as the sustainable drainage schemes, increased capacity of the airport, an improvement on the current facilities, the planned redevelopment on brownfield sites, the creation of jobs, increased revenue for the airport's owners, and potential for educational opportunities for Cornwall schools and colleges. A full SWOT analysis has been performed for this project. However, in brief, its major strengths include the large amount of government funding available and the fact that it was shortlisted as a potential British site and is the only one of 6 to be located in England. However, its major potential weakness is that there is currently no established client base for space tourism, but that is because it's the first in the UK and so presents a large opportunity for being a turnkey project. That is provided we can get the additional funding required over the other shortlisted sites. This project will pave the way for an entire new space-based industry within the UK, as well as bringing in much-needed investment to the local area. Our designs will make OCUVI one of the region's leading consultants in spaceport engineering and design, and the project presents a unique opportunity to invest in our vision. Thank you.